This is a paper by Mark Wolf, Yanxi Liu, and myself. Mark wrote this paper when he was an undergraduate student working in our lab on his honors thesis. He has since graduated and he's working full-time at Progeny Systems. Our goal is to match building facades from aerial views to ground-level street views. We build on previous work in our lab for detecting and matching facades across two aerial views. That's an easier matching problem because the viewing directions and lighting conditions were similar. The current work is much more challenging because of large differences in viewing direction between the aerial and ground level views. The images are taken by different cameras at different times of day, perhaps months or years apart. Street views suffer from partial occlusions such as light poles, street signs, or tree foliage. And finally, the repetition of windows and other architectural features on the facade leads to ambiguity in local feature matching approaches. So the key idea developed in this work is to use pattern repetition as a strength rather than as a weakness. We leverage the regularity in the form of a translational lattice to form a representation suitable for wide baseline illumination insensitive matching. We first extract lattices from each aerial facade and from all of the street view images. Note that the lattices do not have to cover the full spatial extent of the surface, just a sample of the repeating pattern. We bring all the tiles of each lattice into alignment to compute a median tile that summarizes the appearance of the facade. This removes the repetition ambiguity and also repairs the effects of partial occlusion or cast shadows. Our task now becomes one of matching median tiles. To account for geometric deformation, each tile is randomly sampled into a set of patches. Appearance features capturing edge layout, color, and texture are extracted for each patch. A fourth feature captures relative spatial location to encourage matches that have smooth deformations. Matching patches between two tiles now becomes a min-cost linear assignment problem solved by the Hungarian algorithm, and the cost of the best assignment becomes a match score measuring similarity of the two tiles. Ranking street tiles based on their similarity to an aerial tile query yields a set of potentially matching facades. We compared our method for retrieving matching facades against local feature approaches such as SIFT and root SIFT, the more sophisticated binary coherent edge descriptor of Zitnik, and the scale-selective self-similarity descriptor, which was developed specifically for aerial to street facade matching. Our approach outperforms these other methods on 3 city datasets: New York, shown here, San Francisco, and Rome. Each row of the following images shows example matches retrieved by our approach. The left 2 columns show a query aerial facade along with its extracted lattice. The next 3 columns show the top 3 ranked facades from street view images. And there's several examples coming. One notable property of our facade level approach to matching is that correct matches can be found even when the street view and aerial lattices have no spatial overlap on the surface of the building. So in summary, by embracing the regularity of urban facades, we achieve wide baseline illumination insensitive matching between aerial and street level facades. For more details, please come to our poster number 10.